Welcome in everyone, John here, staff software engineer, 10 plus years of experience, lead maintainer of Latterly.io. And I am revisiting, so we have the Latterly Leetcode kata, the recommended introduction to Leetcode with a meager 12 problems, really beginner friendly. Right here, but in light of research from interviewing.io, I am reevaluating the kata, or extending it really. So the kata will remain, but we'll add the Latterly 300 and the Latterly 500 with 300 and 500 Leetcode problems respectively. A major component of that will be Neetcode. So here we're practicing Neetcode. I like the Neetcode roadmap. I don't like the Neetcode core skills. I don't like these. For example, design, like I've talked about this in the past, the way they have you design these structures is not the way we really use those structures in Leetcode problems. But the Neetcode 150 is great, and even the Neetcode 250 I like with modification. And so I'm going through the problems, figuring out which specifically I'd like to avoid. I think the short answer is like these three. DP, 2DP, bit manipulation, probably skip those. But anyway, so that'll be the TLDR, like here's like 100 problems, and then there's the kata, and then we'll add like a couple hundred other problems. But for today, just working on the anagrams problem, which I could not solve last time. So we're practicing it until we can get it. And this may be a bit of studying. I think I remember the high-level idea here, but the implementation still has not been drilled into my head effectively. And the stream topic is Neetcode, not Leetcode, because we are taking a structured approach. We're doing Neetcode. We're not doing Leetcode. Okay? Start right at the top. I think it's fine to start with arrays and hashing. Easies are done, and then the group anagrams. It's trickier to me. I think the approach here is that, so we don't want to use the counter. You could use the counter object in Python for detecting a single anagram, but looping over it is not so simple because the counter object is not hashable. So the same idea, but we'll sort of roll our own counter and hash it ourselves. And there's a few different ways to do that. You could do a stringified key, you could do a tuple key, you could do a frozen set key. I think any of those could work. I like the frozen set the least. And maybe that's dumb. Maybe the frozen set is great. Maybe the frozen set is the way to do it. Because you can just take a set of a string. In the stringified approach, you can use the ORD method to get a numeric representation of a string. So we'll try out a couple different implementations and probably consult the solutions. I think the Leetcode recommended solution uses the ORD method. I'll read through the problem briefly. Given an array of strings called strs, group the anagrams together. You can return them in a list of any order. So I'll call this the result list. We'll eventually return the result list. But we need some sort of a caching structure. Maybe we could use the list itself. So if I use the list itself and I populate it with strings, that's easy enough. I'll need to sort each string internally, which introduces a log n to the complexity. I think that's not optimal. Okay, let's do the brute force, and I'll probably have to look up a more optimal solution. So I'll call this cur sorted, which is cur string.sort, and I might need to go sorted. I get sort and sorted mixed up. An alternative would be cur sorted equals cur string. I think those are equivalent, but we'll figure it out when we try to submit, and it tells us how wrong we are. Okay. So now I have this sorted string. The sort of naive thing to do is if cur sorted in result list. Oh, this would be for sublist. We'll get the index. Welcome in. Feel free to tap the like button so the algorithm will send the video around. Thanks for being here. Let me make sure I don't miss any chat comments. And I can't see the TikTok chat, but you can visit the bio and join YouTube or Twitch, and I'll be able to see your comments there. Okay, so if the sorted form is already there, then we will append it. Otherwise, we'll append a new sublist. Okay. And I don't need to iterate through this. What I can do is get the first element. So there's guaranteed to be at least length 0. Since we initialize every sublist with an element, that element 0 will always be there, and we can just resort it. How does this work? Has no object sorted. Okay. We'll do the alternative. Has no object sort. Okay, so we can, what, split it then? So this will now be a list of characters instead of a string. And the splitting and unsplitting is going to be like really inefficient. But anyway, we'll do this just to get a brute force going. I guess I'll do this again here. Empty separator. Can I do this? I think so. Okay. So I got a wrong answer. What is this? What is this producing? AET, AET. That's what I expect. Nothing is getting appended. That's really strange. Yeah. So the issue is that this is in the inner block when it shouldn't be. Let's say is anagram is false. Okay, so here I have a few groups. Bat, I have the group of bat, 8, eat, and tea. I did not join them. Yeah. So since they are going to be string lists, this doesn't work. This doesn't work. I got the first L sub sorted. Okay. It's probably going to time out, I think. Let's see. Oh, and I shouldn't have the print there, that's for sure. But that removing the print won't fix the fact that it's pretty inefficient, eh? Yeah, TLE. Cool. So this is the right implementation, but it's too inefficient. So how can we improve the efficiency here? Well, if I don't need to do this splitting and sorting over and over. So I'll just naively cache it. Sorted cases is a set, and a set won't work because I need to preserve the index. So I'll do a hash map instead. Let's do sorted anagrams, value is index. Okay. So here, if not is anagram, then we want to put it here. And what will this do? I think it will let me get away from this bit. So instead of if not is anagram, if cursorted not in sorted anagrams. In here I can do an if else. So I'll get the index this way. So it's an anagram, so we append it at the index. The value here is cur sorted. Okay. This will append it in the proper location, assuming that we cached it properly, but the caching is not done. So to cache it, I want to take the sorted form. I want to take the sorted form and set the index. Anagram, the index for the anagram storage. The index for the current anagram. And that will just be the length of the result list. So in the base case, it'll be 0. Let's see how this does. Oh, unhashable type list. Okay, we have finally gotten to the point that I was thinking through how to do this. So now that we're here, I can see more clearly the best way forward. So the options were a tuple, a frozen set, or a string. I could just use the string literal as the key. Yeah, that seems pretty intuitive, I think. So we want to use the anagram as the key anyway. So let's just join it, yeah? And maybe there's a performance, I guess that's the reason for using the tuple, that preserving it as a tuple. Is it any faster? Maybe casting list to tuple in Python is O of 1. It's not obvious to me, but maybe that's the reason that some people go for a tuple or a frozen set. Well, the frozen set now is pretty clear, isn't it? It is, you have to do one pass through, but then you don't incur the sorting cost. So I want to do a to-do here. To-do try frozen set key. For now, I'll go for the tuple. No, I want to try all three. So first I'll do the string, then I'll go tuple, and then I'll go frozen set. Okay. So for the string, cursorted.join. Now it's going to be a string key instead of a list key. Okay. But now that I've done this, when I look it up, I also need to make a joined form. And we can see the inefficiency here with these joins. But let's continue. List attribute has no join. Am I mixing up my languages? Is that just the JavaScript way? Can I turn this into a string this way? Okay. Okay, so that was acceptably fast. I saw some comment in the chat before I continue. Let me check that out. Oh, no, that's a bot. Okay. Reminder, if you're on TikTok, I cannot currently see the comments. Sometimes it like works later. I don't know. how to reliably see those. I might be able to see them later, but for now, if you want to go to the bio, you can send the chat message on YouTube or Twitch. Okay, so this is definitely better than what I was doing previously, but it's still not optimal. And the reason it doesn't seem super optimal is because we're sorting and joining, and potentially we can avoid that. I don't need this is anagram false flag. False flag. I don't need that anymore. So yeah, instead of turning it into a list and sorting it, let's just make it a set. And can I do frozen set? The reason to avoid frozen set is that I can't remember the syntax. We'll save that for last. I'm going to have to look up. I don't know if I turn it to a set and then call freeze, or if frozen set, I need to import it from somewhere. Maybe that's how to do it. I'm not sure. For now, let's go for the tuple. And I can just do this, I think. Now that it's a tuple, does it have still call sort? Maybe. Was that the only change? Stir has no attribute sort. Okay. So do we still need to sort it as a list and then turn it into a tuple? And we're sort of magically faster. It must be the case that to go to tuple from list in Python is faster. That must, because look at the result, right? The result is just faster. Okay. Well, that's great. So we've gone from string to tuple very easily. Just changed the cast type. That was really nice. But we haven't avoided sorting. Okay, so let's go for the set. Now it is curse. Now it is a curse set. I'm actually going to comment that. I'm gonna just take this over to ChatGPT and say, hey, like, make this a set. Frozen set does not preserve the count. Yeah, that's true. Here's how you can optimize the code by using character counts to avoid the overhead of sorting. There's that ORD method. Okay. So we're using ORD. Ah, I get it. We're just checking all the letters and counting them. We're rolling our own character counter. Yeah. This is the most optimal way to do it that avoids sorting. It's just hard for me to remember. It's hard for me to remember. Okay, and they want to use a default dict. That's fine. I don't really care. I actually prefer not to use the default dict because of my personal memory issues. So for each string, I'm going to just get all the letters, and there's 26 of them. And I loop through the string and I increment the correct position. That's why I'm subtracting A. It's an integer representation. As silly as this sounds, remembering 26 letters in English is tough for me. Can I do ORD Z? Okay. ORD Z minus ORD A. And does that give me the right count, or is it off by 1? It's off by 1. Yeah. Okay. So car count is ORD Z minus ORD A plus 1. That should be 26. Yeah. So now, instead of sorting, I can go for this O of K. It's just always that length. Call this a character count array. And that is going to be 0 times character count. So now what do I do? Now, this part is clear enough. Loop through the characters and increment the right index. So now I want to turn it into a tuple, use it as a key. If it already exists, append, else create it. And that's where the default dictionary would save us a few lines. But I'm happy to do it this way. Practically, that doesn't save me much time during the interview, and I avoid like fumbling around like, where do I import this thing? So if it's there, we'll append to it, and if it's not there, we will initialize it. Oh, no, we don't initial. I'm doing this wrong. If it's there, we append to it. And if it's not there, we initialize it. That's correct on the sorted anagrams, but I'm not using the result list. Okay. I want to store the index, not the string. Because I might get a key error, I'll use get instead of looking it up. And I'll use greater than -1 to avoid the case where it is seen at the 0 value. I don't like that either. Oh, okay. Here, we can do a default of -1. Okay. So if I've seen it, then I append to the map. No, that's wrong. If I've seen it, I append to the list. Otherwise, I create a new one. I think that's right. Let's see. Oh, and that worked, but it threw me back in efficiency. That's crazy. Result list.values will save some time. Can I do that trick here? Yeah, okay. Can I do that trick here? Sorted anagrams dot values. I guess so. So I don't need the result list at all. Cool. I like that one. I don't need the result list at all. And I'm still, it looks like I'm still at the same performance bar, but I think that's just because of the test cases. Yeah, I like this solution a lot. What do you think, chat? Default dict is in the collections library, is that right? Yeah, okay. Well, if I can manage to remember that, I guess I can shave 3 lines off of this. But this looks pretty good to me. Okay, I think we can consider this done. Valid Sudoku, that's wild. Let's try it. I'm terrible at Sudoku. Determine if it's valid. Only the filled cells need to be validated. Okay, so I don't need to solve it, I just need to validate it. Each row must contain digits 1 to 9 without repetition. So then example 1 should be false. Well, the row doesn't contain digits 1 to 9. It can be partially filled. All right. Okay, so what are some approaches here? I could check all rows and then check all columns, but then I still need to check the submatrices. On the other hand, if I check the submatrices, if they're all valid, then the whole thing is... Nope, that doesn't work either. I can't just check the submatrices. So I think we need to do a 3-pass solution. I think I need to check rows, columns, and submatrices. I think I need to do each. I think I need to do each. Looks like we can still solve it in O of n optimally from a time complexity perspective. O of n, where the whole board is an O of n. If you wanted to go by length or width, then it would be, you know, OLW or OL squared. So you could call it squared with respect to the length, but it's constant with respect, not constant, but linear with respect to the cell count. I think that's right. I mean, the implementation I have in mind is just a 3-pass. It's pretty straightforward. So you do each row, you do each column, and then you have to do whatever, a mod or a slice for the subsections. Here we get a repeated 8. Okay, I guess let's try the code. And then if we get all the way through, we'll return true. You can do a set of the numbers 1 through 9. Am I guaranteed that they will? Yeah, they're either going to be a digit or a dot. All right, so that will check the rows. The implementation here is similar, but this line needs to change. What's the syntax here? To get the columns. Like the width is always equal to 9, right? So I'll just hard code it as 8 because we're going to use the 0. So for call IDX in range width. I think there's a more elegant way to do that. So I'm getting the row 0, column 0, 1, and so I'm scanning vertically. That's working. Yeah, so I think that's right. Let's see what we're doing so far. Call is not defined. Okay, good. Okay, so it says accepted, but that's not right because we haven't done the submatrices. I guess is it really just like a keyboard grinder? It's like it's not that complex, but you have to churn out a lot of code and it's not pretty. I feel like I'm missing something. I feel like there's a prettier way to do this, but it's working. Okay. To identify the submatrix, we can divide by 3. We can use floor division. How do I want to do this? I could get a I mean, the dumbest way would be to do like 9 iterations. Maybe that dumbest way is right. So that code will be so ugly if I do it that way. It'll work though. Okay, and what's the alternative? So I can do this submatrix thing, and I can calculate like slices or something. The alternative would be if I pass through the whole thing once, and I have what, like a dictionary of scene maps? I'm just going to look up the solution. I want to see how they write it. A hash set. So they call them boxes instead of submatrices. N is 9, use a hash set. So they're going to check the box as they go along. Yeah, that's the alternative, right? So it's O(n) squared where n is the board length. Yeah, I think mine is more memory efficient, yeah? Yeah, I think I have O of 1 memory, so I think I beat that. Bit masking is crazy. So why is the space complexity n squared here? We need to create 3n arrays. This is weird. It looks like I'm actually doing a different approach than these. I'm not understanding why it's n squared space complexity. If I do one submatrix at a time, I'll never have the full thing in memory. Right? So here I've got memory up to n. Here I've got memory up to n. And here I've got memory up to... Oh, is the idea that for any slice... I guess I was thinking each submatrix would have memory up to n as well. The solutions are really focused on doing a single pass. It should be mentioned that a simple 3-pass solution exists with optimal asymptotic complexity. Yeah, that's basically what I thought of, right? 3-pass using counter, 3-pass Python solution. So this is what I was implementing, basically. I don't understand why they're doing a set of a list here. Intuitive if you never saw this question before, but time consuming to code up. Yeah, exactly. Exactly. So how do they do this here? In range 093. That's interesting. 093. Yeah, this extra parameter to the range I didn't think of. That's really smart. So it's just a 3 interval. I like this one. Let me hold on to this. You get to upvote. Why did nobody upvote that guy? That was cool. So that's an option. Let's go see if I have some other solutions. I click Python and then it's like the first one is C++. That's kind of silly. It's going to be bit masks. Yeah, no, I'm not doing bit masks. Maybe I should be doing bit masks, huh? So how does that work? You just sort of blank out the one that you've seen. This is not intuitive to me either. Golly. Default dict set. This is not intuitive. It's a dictionary. Yeah, it's a dictionary of sets. Okay. It's a dictionary of sets. It's readable. It makes sense when I read it, but I don't think I'll remember that in an interview. Definitely get an upvote though. How do I upvote this guy's answer? I don't know. I don't know how to upvote the answer. So, oh, down here. Okay. This is some crazy Leetcode jujitsu right here. I'm not liking any of these. Okay, this is a little better because I'm doing a single set instead of the default dicts. I can do a, this is a little better. Yeah, I like this one. This is like a one pass condensation of my 3-pass solution. So it actually is relatively intuitive. It's just doing everything in one pass where I was thinking to break it up into 3. I guess I should do this because literally no one is doing... Like, this is the closest to the expanded form. Even this is going to use a grid set. All right, let me keep with this as the expanded form then. So this is a 3-pass solution. And then here's the 1-pass solution. Bless you. So, I like the name, row start. It's going to define my quadrant is not quite the right word. Row start, call start. Okay, and then this, I don't think I would use this. I would just call this scene. Okay. And so I'm literally just doing like, yeah, from row start to row start plus 3. But I would be reworking this similar to this way. So what's wrong here? Okay, what's wrong here is that this, so I'm defining a new set for every submatrix. It does strike me that I think these should be 2s. Is that the only issue? No? It's hard for me to read this. Chat is so great. Yeah, so the issue is in this upper right quadrant, that it has 2 1s. So why am I not catching that? Okay, dope. Incorrect subgrid size. Okay, then is it because I'm using 8? Yeah. Okay. I was overcorrecting and off by 1. So there should be 9s. So I was overcorrecting the off by 1, so now let's see. Okay. Got it. I like this solution. I like both of these. The one pass is obviously cleaner. The problem is, will I be able to remember it? So yeah, in a real interview context, I would go for this 3 pass, and I'd just crunch out the numbers, and then I would definitely be able to talk about the 1 pass, but I would probably struggle to implement it. I would definitely struggle to implement it. But I think this approach of a set that has tuple keys, for me, this approach is more intuitive than the default dict. Cool. Hey, thanks for being here, chat. That's going to be it for today.